We've heard about the Yellowstone Supervolcano erupting multiple times in the news. In fact, it was even discussed as a possible explanation for the global cooling event of 1816, the year without a summer. But how likely is it to erupt in our lifetime? We will discuss that in this episode of SCI Show News. Yellowstone National Park straddles the northwest corner of Wyoming and small portions of neighboring Montana and Idaho. It's home to more than half of the world's geysers, as well as hot springs, mud pots, and the largest concentration of bison in the United States. And yes, it sits atop one of the world's largest active supervolcanoes. The park itself was established in 1872, making it the first national park in the world. While many people visit each year to see its geysers and grand prismatic spring, others come to experience its hydrothermal wonders. The most famous of these is Old Faithful, which erupts every 90 minutes or so and shoots boiling water up to 180 feet into the air. Yet both of these popular attractions are comparatively small potatoes when we zoom out. That's because they are located within the 43 by 28-mile caldera of the Yellowstone Supervolcano, which lies mostly beneath Yellowstone Lake. The magma chamber beneath Yellowstone has been rumbling for the past 2 million years, giving rise to 3 major eruptions during that time. Some scientists estimate that the magma chamber extends at least 60 miles beneath the surface, and while no one can agree on just how much magma is down there, all experts agree that it's a lot. In fact, the total volume of magma in the Yellowstone hotspot is thought to be as much as 20,000 cubic miles. To put that number into context, that's about 2.5 times the volume of Mount Everest. But what exactly is a magma chamber, and why is it important? Well, you know how coffee makers have a carafe where they keep the coffee warm after brewing? A magma chamber is kind of like that, except instead of coffee, it holds molten rock deep beneath the Earth's surface. And instead of your countertop, it's typically several miles underneath the surface. Magma chambers form when hot molten rock known as magma pushes up through cracks in the crust but does not quite reach the surface. Instead, it pools beneath the surface and creates a sort of underground lake. Eventually, if enough magma accumulates, the pressure from the weight of the overlying rock forces the magma back down into the mantle, restarting the cycle. Now don't worry, we aren't going to get into plate tectonics here, but it is worth noting that the reason magma chambers exist is due to the movement of tectonic plates. There are several types of magma chambers depending on their location relative to plate boundaries. For example, some form along divergent plate boundaries where 2 plates move away from each other, allowing magma to rise and pool up. Others form over mantle plumes or hotspots, which are columns of hot rock that originate deep within the Earth and punch up through the lithosphere. That's the case with Yellowstone. Yellowstone is located above the North American plate, which is moving roughly southwest to northeast. Meanwhile, the hotspot itself is stationary. This means that as the plate slowly moves over the hotspot, the rocks are heated and eventually melt, creating pockets of magma. As the pockets of magma cool, they solidify into igneous rock. And if they stay beneath the surface long enough, that igneous rock can become part of the surrounding country rock. However, every so often the magma makes its way to the surface and erupts. And those eruptions are the reason why we have the Yellowstone Supervolcano. The youngest of the 3 major eruptions happened 640,000 years ago. And while that sounds ancient, it is actually pretty recent in geological terms. In fact, researchers can still detect high levels of heat and seismic activity in the region, indicating that it may not be completely dormant yet. The last smaller eruption happened only 13,000 years ago, and left behind the obsidian cliffs now known as the Yellowstone caldera. Since then, the supervolcano has been quiet, or so we thought. You see, while there hasn't been any sign of an imminent eruption, researchers have detected signs of unrest in the last few decades. For example, the area surrounding the supervolcano's magma chamber has risen and fallen as much as 6 inches over the course of just a few years. There have also been swarms of small earthquakes near Norris Geyser Basin, and steam-emitting vents known as fumaroles have increased in number and intensity. Even Old Faithful has acted a little funky, with its predictable geyser eruptions becoming less regular in recent years. In 2018, scientists announced that they had discovered an interconnected network of magma chambers beneath the caldera. They made the discovery after analyzing data collected in 2015 by a seismic network maintained by the University of Utah and the Yellowstone Volcano Observatory. Using sensitive seismometers, the team could pick up tiny changes in the ground's vibrations when magma moved through the underground plumbing system. They found that there are at least 8 magma chambers below the lake, the majority of which were previously unknown. Importantly, this discovery suggests that the magma isn't just sitting in one giant pool as previously assumed, but is instead circulated through a network of interconnected chambers. Since then, researchers have continued to monitor the magma chamber and look for signs that the system is getting ready to blow. In 2021, a group of scientists published new findings based on over 20 years of seismic data. Their results showed that magma is continuously supplied to the shallow magma chamber and that the magma is well mixed, resulting in a homogeneous magma composition. According to lead author Michael Poland, chief scientist at the Yellowstone Volcano Observatory, this finding supports the idea that the magma chamber acts as a self-regulating system. That means that if the magma chamber becomes too full, excess magma is pushed back down into the mantle and recycled back into the reservoir where it came from. If this is true, it would help explain why large eruptions don't happen more frequently. Of course, this self-regulation doesn't mean that another eruption isn't possible. In fact, according to Poland, he and his colleagues don't think it's a matter of if an eruption will happen, but when. They estimate that there is a 6 to 14% chance of an eruption in the next 30 years. The good news is that researchers feel confident that they would be able to give people plenty of warning before it happens. If you remember earlier this year, a magnitude 7.8 earthquake shook parts of the central and eastern United States, leaving many wondering if it was a harbinger of things to come. But according to a report from the U.S. Geological Survey's Yellowstone Volcano Observatory, the earthquake did not pose a danger of eruption at Yellowstone National Park, but it did help researchers better understand the magma chamber beneath the park. You see, when an earthquake hits, it leaves behind a record of how long it takes for seismic waves to travel through the ground. By measuring how fast the waves move, scientists can learn more about the composition of the material they're passing through. After the February earthquake, researchers analyzed the data and determined that the magma chamber contains liquid magma rather than a more solid, sluggish lava. According to the USGS, this finding is consistent with previous studies and shows that the magma is still quite fluid, which helps prevent large eruptions. So rest easy. At least for now, we probably won't be seeing anything like the movie version of Yellowstone anytime soon. Now that we know that the magma chamber is basically a self-regulating system, it seems that our best bet for preventing disaster is to ensure that our elected officials are aware of the latest scientific findings. Luckily, SCI Show News has a partner that can help us all deliver real results. It's easy to feel helpless in today's political climate, but you can make a difference with a little help from our friends at 5 Calls. When you sign up, 5 Calls will give you 5 calls to make to key lawmakers in your state twice a week. Each call only takes about 2 minutes, so it's a really easy way to spend just a few minutes of your day making a big impact. All of the calls are recorded, so you won't have to worry about saying the wrong thing. Plus, you can easily switch up the issues you care about as they come up. With 5 Calls, it's that simple. Thanks for watching this episode, and thanks to our sponsor for supporting it.